This is Elaine McCormick for Lab 7 at home, the black hole. My main problem-sets objective for this lab was to use the relationship of gravity between objects, specifically a star and a black hole of an unknown mass, and using data given about the star's motion, determine the mass of the black hole. Then I'm going to discuss the relationship between Fnet and change in momentum. The main result for this lab was I found the mass of the black hole, which in my case is 2.77 e to the 31, and then I found that Fnet and change in momentum are equivalent in values for all components. So let's look at how I first found the mass of the black hole. I created a code in VPython that took in the position of the star from my data, which you can see down here, as well as the initial position of my black hole. And then when I run this code, it takes that and puts it into the gravitational force equation, which is the only force acting on the star, and it outputs, you can see it runs through there really quickly actually in this one, and it outputs my mass of the black hole. And that I got using the gravitational force equation, which is G times m1 m2 over r squared. And you can solve for m1, which in my case was the mass of the black hole. To make this clear, for the video, I used another computer to run and show you my discussion of the change in momentum as compared to Fnet. So you can see here, I use the code which shows the star data as it runs. You're going to see a black arrow which represents the net force, a blue arrow which represents the component of the net force in the parallel direction, and then a red arrow that represents the net force in the perpendicular direction. So I'll run that here. Hold on, there we go. So you can see as this moves, the directions of the arrows and then the magnitude based on their size. So that's during my data. You can see that the black arrow, which is the Fnet, is always towards the center of the circle due to centripetal motion. Then the blue arrow is the parallel component, which is always tangent and goes in to the motion, and then the red arrow is the perpendicular to the momentum, which is also pointed inward, but is not the same as the Fnet arrow. You can see here that the way it works is my parallel component plus my perpendicular component gives me the Fnet, and based on the sizes, that's how we get where the arrow is, because that represents the magnitude of those forces. So let's discuss this a little bit and what this means. So we found that Fnet is equal to the change in momentum for all components. So these represent the Fnet perpendicular parallel and Fnet just combined. They're the same exact arrows as if it was the change in momentum parallel, change in momentum perpendicular, or just change in momentum. These are not the same thing. Fnet is not observable, but change in momentum is. So that's why, that's how they're different, but the values are always going to be the same, and they're always equivalent. The Fnet parallel, or change in momentum parallel, changes the magnitude of the momentum, while Fnet perpendicular, or change in momentum perpendicular, changes the direction of the momentum. So those are what Fnet and change in momentum are. And so moving from there, what if? Let's say I did this experiment again, except for this time my star data was different. The black hole is still in the same position, and its gravity is still the only force acting on it. Well, if I have that being the only force, the Fnet is going to be the gravitational force, which is, as I stated, G times m1 m2 over r squared. So you'd be able to see the difference and determine the new mass of the black hole based on the fact that its gravity is the only force acting on it. The star's path, it would make a larger circle if there was a weaker gravitational force, because it would not be pulling it in as strongly, and therefore the mass of the black hole would be smaller. Same thing if the mass of the black hole was larger, it'd be a stronger gravitational force because the radius would then be smaller, and so it would be a smaller circle. And then if it was just the same mass, you wouldn't see any difference at all, because it'd be the same circle based on that being the only force acting on it. So overall, we found my mass of the black hole and discussed the Fnet and change in momentum. This is what I got.